Okay, now this is a mixture of the different story problems you've had in the past days. You deposit $100 in an account that pays 4% annual interest compound quarterly. Find how long it will take the account to reach $1,000. So you've got dollars and years. Years is X, dollars is Y. So dollars per year. Now, this is not a constant dollar. There's a percent per year. Annual means per year. Plus 4%, that's interest, so it's going to be plus 0.04. Now, look for the word quarterly. See if you have to divide that by 4. Yeah, it's there, so that has to be divided by 4. $0.01. And that's what I'll be adding to one whole when I get the equation set up. So blank times blank equals blank. So money original times a percent and the money new. And we have our power here with the number of years. But since I had quarterly, the years are going to have to be multiplied by 4. That's if it says quarterly. So the original amount's $100. Percent, I got to add 1 to, that's 1.01. Okay, years, I don't appear to have a years because that's the answer. Okay, so it's 4x. And then $1,000. Now, this is more than just a calculator problem. Okay, you can use a calculator for various aspects, but you can't. It's not the end-all, be-all. So I have 100 times 1.01 to the power of 4x equals 1,000. Where's variable at? It's at here. It's up here, so I need the circle split. And 4x is equal to log over log, the base I know, okay? I know that that's 1.01. I do not know the numerator because I had this 100 multiplied, so I have to undo the multiplication of 100 using inverse operations. 1,000 divided by 100 is 10. Now I'm going to do this, but I'll divide by 4 then after I calculate my answer. Okay, 58 years. Long time. Yeah, you got to get from 100 to 1,000. That's quite a bit of a growth range when you're going by percents. Okay, now my next problem. You deposit $100 in an account that pays 6% annual interest compound quarterly. Find how much we're worth in 6 years. Finding the money is an easier problem. Okay, I don't have to do as many operating. X is years, Y is money. So dollars per year. Again, 6%. So interest is plus 6. Okay, so again, that's a growth. So blank times blank equals blank. Power. Because I take money, the reason this has to be set up differently is because we take money times percents, not adding. Okay, it's not repeated addition. Okay, so original money, the percent, this is the years. Oh, shoot, okay, I didn't do what I was supposed to do here. Okay, we need to write that as 0.06. Now look for quarterly, it's there. Now we need to divide it by 4. Okay, again, that percent needs to be a decimal, then check for quarterly. If quarterly is not there, you just roll with the 0.06, okay? But if it's quarterly, it needs to be divided by 4, okay? Plus 0.015, and then it's 1 plus 0.015. Okay, so the original amount's 100, sorry about that. Then for the percent, I add 1 plus 0.015, 1.015. Okay, now, since I divide that, the years also have to be multiplied by 4 on quarterly problems. Okay, so how many years I have? I actually have that. I got 16. So 4 times 4 is 16. And the money that is new, I don't have that because that's the answer. So money's y, okay? Use the appropriate variable, but y has no operation, so it's just a calculation. 100 times 1.015 to the power of 16. That's $126.90. If you just put 127, I wouldn't be mad, okay? So again, quarterly, after percent's a decimal, divvy it up by 4 before you add the 1, and then the 4 also has to appear before the years in the exponent. Okay, and then my last example. Your new computer costs $2,600. The value of the computer decreases by a constant percentage each year. After 5 years, the computer is worth $1,154. Calculate depreciation rate. So dollars in years. Years is X, dollars Y. So per year, dollars per year. Now it's a percent. I don't even know that though. So that's P. Okay, that's decreasing. So it's a decay. Not that that's all that important. The math will take care of that. Blank times blank equals blank. So you got your money original. Then the percent to the power of the years, and then money new. So my original, some people ask, do you ever not know the original? It's possible, but I don't really do it in this class, okay? So P is my percent, and there's none of this quarterly stuff, so I do not put the 4 there, okay? I don't usually do quarterly with the P problems, okay? So we just put the simple years, which is 5. Okay, then the new amount's $1,154. Okay, this is more than just calculator. So 2,600 times P to the 5th power equals 1154. Now the variable's not in the power. The power is just 5. So don't circle, don't split, don't log over log. Okay? We're going to use the 5th root, a root with a 5 in the index. But before that, 2,600 has to be divided out. Okay, so P to the 5th. Okay, 0.44. Now I undo a power with a root, okay, and it's got to be a 5. 5th root can't be a square root. That's for second power. So 5 second. This key here opens up the root, and then 0.44. You don't go 5 second. It can't be the x squared key. Because then they'll think it's 5 times the square root. No, it's a 5th root. Okay, 0.85. Now you got to remember, you need to minus 1 and then times 100 when finding your percentage. Because 85 is not the percentage it was going by every year. It went from 100 to 85, which means it dropped 15.